to be your instructor for the day. In today's session, we are going to understand the word machine learning and how it works. We are going to understand the science behind machine learning and how we are going to understand and deep down the parts of machine learning, where it has come from, and much more. So let's dive into this module, which is machine learning module. What is machine learning? Basically, machine learning is a way of teaching computers or machine to learn and make decisions of their own without being directly programmed for every task. So you must have seen around you. And now start figuring out in today's from morning till now, how many machines you have seen which have worked automatically without it being programmed, right? You must have seen that your mobile phone responds to your face ID. When you are capturing pictures, it does, like when you smile, it captures pictures. It is also an example of machine learning. Image recognition, whether you are wearing mask or you are wearing glasses or not. On traffic signals, most of the police, they have done that camera for the image sensing only. Whether you are wearing helmet or not, they capture the picture, whether you are speeding or not. So these are all examples of machine learning. Let's understand how it is changing the world around. It is changing the world and how jobs are done in many industry. When we talk about in many industry, you must probably use machine learning every day without realizing it, like unlocking your phone with your face recognition, or your office biometric machine, or your attendance when you are entering into the college or school. Machine learning is now everywhere and very important. If you want to become a data scientist, or you are aspiring, or if even if you wanted to enter into any job profile, machine learning and AI are life learning skills and use them to solve business related issues or real business problems. So let's understand what are machine learning concepts, from where machine learning has come. So let's move to the next one. Here, let's understand how machine learning, it is going to give you a deep insight. When we talk about machine learning is a science of teaching machine, right? So it is actually a subset of artificial intelligence. We cannot say that all artificial intelligence is machine learning, but yes, all machine learning is artificial intelligence. You must have learned Venn diagram. So it is exactly like that. The broad science of making machines act like humans, that is called that is called artificial intelligence. When we talk about machine learning, which is subset of AI, it is how you are going to train a machine to act like humans, to predict and make decisions. When we talk about deep learning, which is a subset of machine learning, it uses brain like structures. Those are called neural networks of complete, or you can say a complex structure, a patterns of large data, right? And that is where image recognition, self driving cars, and chat GPT like thing come into picture. So these are, I think now you are at a stage where you can understand what is AI, what is ML, and what is deep learning. Now let's focus upon machine learning and let's see what are different types of machine learning. When we talk about different types of machine learning, here we have the first one is supervised learning. The machine learns using labeled data, where the input with correct output provided to make predictions. For examples, you must have seen email spam detection. So all the emails which are going in junk or archive, those are already trained in a manner where machine learning is being put. So that is an example of supervised learning. When we talk about the second part, which is student grade prediction, that is also an example of supervised learning, where predict a student's final grade based on past attendance, assignment scores, and test result. The third example which I can give you, that is face recognitions in phone. Recognizing your face using image labels with names. Now, let's understand what is unsupervised learning. Here, the machine learns patterns from unlabeled data. It tries to group or organize data on its own. Suppose we have kept different types of fruits in a basket. Some are round shaped, some are long, like banana. So if you wanted to differentiate or group them, then you can easily do with unsupervised learning, right? So grouping students by their learning style is also an example of unsupervised learning. Automatically grouping students based on how they interact with content, content like videos, quizzes, and readings. Market basket analysis, like I have already shared with you, identifying which items often bought together, like chips and soda. Similarly, if we talk about new article categorization, which is like grouping similar news articles without knowing their categories, that is also can be done with the help of unsupervised learning. Now let's talk about semi-supervised learning. Semi-supervised learning uses a small amount of labeled data and a large amount of unlabeled data to train the model. When we talk about data, what exactly is data? Any information which you have, whether it is in the form of video, it is in the form of pictures, or it is in the form of text. Everything which you are using in your mobile phone, in your computer, that is a form of data. So if you are taking a label data, a clean data, then that is going to come under supervised learning. If it is not that clean, but can be grouped and created different categories, then it is unsupervised. Now let's talk about semi-supervised learning, where a small amount of labeled data and a large amount of unlabeled data club together to train a model. For example, online language translator. You can learn from a few human translated tests and a large number of unlabeled ones, like photo tag selection or suggestions like Google Photos. Learn from a few tagged faces and then identifies the similar one. Then we have educational apps. Label a few quiz answers and the app uses them to improve grading for others. So these are all examples of unsupervised, supervised, and semi-supervised. Now let's deep dive into reinforced learning. Reinforced learning, that is a kind of machine learning where the machine learns by trial and error method. It gets reward for good actions and penalties for bad. For example, self-driving cars learn to drive by rewarding safe decisions like stopping at red lights and moving at green lights. It is going to stop when there are any obstacles in front. Second example, you can see that is game playing boards like chess or Pac-Man. Learn by trying moving and getting feedback or win or loses. And the third example, which you can see, and you have been using it, that is robotics. A robot learns how to walk by trying movements and improving over time. So these are all examples, and these are the types of machine learning. Now, I hope you are in a place where you can actually put and categorize all the actions, all the machine learnings, all the machines which you have seen since morning. So keep doing that. Meanwhile, let's understand in deep context of how supervised learning algorithm is. When we talk about linear regression is a type of regression which uses predicting a numerical value. How you are going to create that? You are going to draw a straight line that best fits the data point. That is one of the examples of, like, what is the formula of drawing a line? That is y is equals to mx plus c, right? And that is how it is going to create a straight line. Example for, let's see, for a student's exam score, which is based on the number of hours that student has studied, right? So this is an example of, the more you are going to study, the higher the score is going to go. Similarly, let's move to the logistic regression. Logistic regression is also a type of classification. It's not a regression, it's a classification. In this, you are going to use predicting two classes, which is a binary classification. It uses an S-shaped curve to estimate probability between 0 and 1. 0 means low, 1 means high. For example, let's predict if an email is spam or not. There you are going to understand it better in the sense like either it is no or yes. Now let's move towards decision trees. Decision trees are basically the most important and most used one. These are the type of both classification as well as regression. It makes decision based on a tree of yes and no questions, as well as it splits the data into different branches using conditions. Whether if this condition is true or not, then move to the next one. For example, predict whether a student will fail or pass based on study time, attendance, etc. So now you can see over here, study time, attendance, these two are different branches. On those two branches, the decision and classification is going to take place. Now let's understand what is random forest. Random forest is also both, which is a classification as well as regression. When we talk about random forest, it improves the accuracy by combining multiple decision trees. In multiple decision trees, when we talk about a forest of trees vote on the best result. On a tree, in simple words to understand, when we talk about decision trees, a tree is made up of different branches. Different branches means different decisions. Then it is going to come to a conclusion by counting how many yes are there. When we talk about forest, in forest there are multiple trees, and in trees there are multiple decisions. So you can club that together to understand how random forest works and how decision tree works. For example, classify different types of fruits based on color, shape, and texture. There, the role of SVM, which is support vector machine, comes into picture, where the type of this particular SVM algorithm type is classification. It uses find the best boundary between two classes only. So suppose if you wanted to figure out or you wanted to differentiate between a dog and a cat, then you can use this type of classification. It draws a line that best separates the two categories. Like two categories, dogs and cats. So it is going to separate the dogs as well as it is going to separate the cats. Similarly, if you wanted to see whether it's a male and a female, as well as if you wanted to differentiate between a rose and a daisy. So these are all examples which you can do using these algorithms and classifications and regressions. Now, I hope you have understood it well, the types of supervised learning algorithms. Now, let's move to the next one, which is unsupervised learning algorithm. The first one is K nearest neighbor, which is KNN. It is both means it is classification as well as regression. It uses the prediction based on the closest data point. It looks at the K nearest neighbors and take a majority vote or average to find out the realistic approach. For examples, suppose you wanted to predict someone's favorite sport based on their interest and age. Similarly, when you are trying to do that, you will be able to use KNN. It is going to find out which one. Suppose if I am the one and someone is guessing which one is my favorite spot. So I'm going to give different examples. Now it is going to find out which one I am playing the most. That is the nearest value, which K nearest value is going to find out. The second one which you are going to understand over here, that is gradient boosting, or KG or XG boost like GWM. So that is basically a kind of clustering which you can use and run over here. How it works: so predict house prices using many different features. So these are all examples of how unsupervised learning algorithm works. K means K clustering. It creates the cluster together where we don't have actual values and data. We usually use unsupervised data and create clusters of it. So now if you can see the difference between supervised learning algorithms and unsupervised learning algorithms, you will find that here it uses clusters, and in supervised you use usually a plain line. So now let's quickly move to the next one, and here we understand value-based algorithm, that is Q learning, which is reinforced learning algorithm, which is based on two values. Here we are going to understand, we are going to learn the best action for each state, that is called Q value, right? Without needing a model of the environment. Here, the idea is going to be that tries different actions and learn from the basic model, learn from the rewards to build a Q table. We are going to understand each and every terminology in our upcoming session. So need not to worry if you are unaware what is Q learning, why we are learning that. Today is just an introductory class where you will understand what are the key values which you are going to learn in this module. Here we are going to understand use cases, simple games like tic-tac-toe and grid world. So this is where Q learning is important, which is optimal actions learned via Q values. For examples, a robot learns with directions to move in a maze to reach the exit and avoid traps. Now let's understand what is deep Q network. It is actually very, very important, and nowadays it is being used extensively. Because if we talk about Q network, here we introduce neural network instead of a Q table for large or more complex environment. The idea of this, why we are using Q network, that is combining Q learning with deep learning to handle high dimension states like images. So with images, if you wanted to see now with ChatGPT, we all have downloaded Ghibli, right? Ghibli is an example of this particular deep Q networks. For Atari games based self-driving simulations, these are all examples. Here it handles high dimensional stages like images, like you put any networks. So it exactly works like different layers are working together. Here we are going to understand AI learns to play Pong and Breakout by watching the game screen, and then based on that it provides the result. Let's understand how policy gradient works. Policy based algorithms which are directly learn the best policy set of actions by improving actions that give high rewards. For examples, let's see how it is working. Works well with environment with continuous action spaces. For example, teaching a drone how to adjust its flying angle to stay balanced, or balancing car. So nowadays you must have seen on LinkedIn that a car uses the center of mass to balance itself. right? So this is also an example of policy gradient. Some of the examples and applications which we can see, that is robotics, gaming like AlphaGo, Roblox, and self-driving cars. So these are all understand machine learning workflow. Machine learning workflow is basically how you are going to create a model based on machine learning. Step number one is collecting data. Get data from different places like files, apps, websites, or sensors. When we talk about files or apps, you must be using WhatsApp. There in the WhatsApp, you must have multiple contacts which are sharing images, music, and multiple files inside it. So that act as a file of data. On websites, the cookies, whatever you are searching, you are feeding data. So that is also a data, means your information. Now let's understand what are sensors. You must be visiting multiple malls every now and then. So when you are entering into the mall, doors are automatically opening and closing. There the proximity sensor works to gather the information where anyone is inside or in the proximity of that sensor or not. When it detects any obstacle, it automatically opens. For example, let's quickly see how you are going to create. For example, when we talk about data, so these are all kinds of data. Collect pictures of cats, dogs, flowers, anything on which you wanted to train your machine. Once you have collected the data, the second part which you are going to do, that is clean the data. Fix any mistake if there is in the data, that is called transformation. Remove the duplicates or fill the missing parts. If there is any null value, you are going to delete the null values or you are going to mark 0 for that. If there are blurry images or repeated images, you are going to get rid of those images. Step number 3, that is pick the important information such as features. When you see, suppose you wanted to create a model in which you wanted to differentiate different cricketers, but machine doesn't know who is Sachin, who is Kohli, right? Similarly, what you can do, you can make a feature which is prominent, maybe the dress, all right, or maybe the betting style. So something should be common when you are going to upload it. Look at the size of the ears or color or fruit. These are all examples of that. Third, we are going to choose a model. Select a machine learning method to teach the computer. Like you wanted to go ahead with regression or decision tree, what model you would like to choose. For example, use a model that can tell the difference between cat and dog. For that, you can use SVM, Scalar Vector Model. Similarly, once you have selected the model, the next part which you are going to do, that is test and train. Teach the model using some of the data. Suppose you wanted to take data, divide the data in 80 and 20 ratio. 80 is for the testing on which you are going to train and 20 for the test. So suppose you, for example, you have entire syllabus with you, that is 100%. You prepare yourself on 100% or 80% and keep 20% for the test so that you will get to know whether you are prepared or not. Then the last one which you are going to do, that is use it and improve it. Basically, you are going to test and deploy the model. So this is how you are going to create your machine learning model. Let's quickly review what we have learned in today's session. In today's session, I have provided you a basic overview of what is machine learning, types of machine learning with examples and workflow of machine learning, that how you are going to create a simple model. In the next class, we are going to learn and understand it in a better way to actually see, and that is definitely going to be without coding. First of all, we are going to understand the workflow of machine learning. We are going to apply test and train methodology. We are going to collect the data in form of voice or in form of images. And then we are going to see how you are going to export the model and see how machine works. Then later in the classes, we are going to get started with Python. We are going to understand different libraries and we are going to create our own data and model. So stay tuned with us and keep practicing. Thank you.